In my last video, we set up the basics of a network manager to start the game, to join an existing room or create a room and then join that. And now I'm just basically going to quickly cover RPC calls, because I think that's just the other main thing that people want to know when learning how to multiplayer and use the Photon network in Unity's JavaScript. So we had the network manager here. To start, we set the player name, made sure we had a reference to the player manager, and the OnGoo took care of all the main menu options here. Creating a multi-room and a single room offline mode. And then we had a quick look at all the different Photon joining commands here. Okay, so just say we've gone through and we've created a player and we joined the room. We created a ship for the player. We've given that ship to the player and we told the player to initialize itself. Okay, so there's lots of variables on the player manager that will want to go onto the ship, such as all the different rotational speeds, move speed and things like that. I'm going to add another one here now just to show how RPC calls work. So I'm going to create public variable ship health. Okay, so now I can pass on a health value to my ship, so that when it starts flying around and takes damage, the damage will be taken off that health value. Okay, so from the network manager script, we first fall down into the initialized player. This is where the network manager instantiates a spaceship, gives it to the player, and the player takes off with that. The player initializes itself, and here we have these RPC calls. I think they're remote procedure calls. This is where you call a function, and every single one of your items on the network will run that function. Okay, so we better set up how to do that first. Now on the ship manager, okay, I better explain that first. Normally your scripts or your classes extend mono behavior. Now you don't see anything like this in Unity's JavaScript. If you create a new C# script, you will see a constructor like this. But basically when you start off in JavaScript, you'll get something like this. Just a parameter strict, you start and you update functions. Now this is already in a class wrapper, but if you wanted to do it yourself, so it does look like the C#, this is what it looks like. Public class, and let's just say this one's called my script. Now that's most important. The name of your script must be the name of the class. Okay? And it extends mono behavior. Okay, and that's it. That's exactly how the C# comes, and this is automatically assumed when you create a Unity JavaScript. But this is how you create a wrapper. So if you wanted to extend other classes, say you would extend your other script here, replace mono behavior. Now we're working with the Photon network, so in this particular instance we want to extend Photon.monoBehavior. Now this includes all the basic classes that monoBehavior uses, but it includes some classes that are exclusive to the Photon. So you get a few extra commands that come along, as well as all the commands you're used to in the monoBehavior. So that's what a class constructor looks like. So that's what's happening here. So if you have an object that is going to be communicating over the network, okay, and you've got a Photon view component attached to that game object, and you want to be calling different Photon class functions, you have to create a class that extends Photon mono behavior. So just like I just showed you already, it's just basically your script but wrapped up in the class definer. Okay, so that's setting up the script so it will use all these extra photon commands. Now, to create an RPC function, something that will run on all instances of your object over the network, here it is here. This is how it's set up. Now, in C#, you'll see it's set up like this. Okay, the square brackets with RPC encapsulated in there. The JavaScript version is just as I have there, and RPC. Now there's a special way to call these functions. You don't just call a function like you normally do here, say display laser and then pass your parameters to it. If you're doing an RPC network function call, you set it up a little bit different. So this has the ship script component already gotten here. Okay, so we're telling the ship script dot photon view dot RPC and then the name of the function as a string, and then you have to set your targets. Okay, you could have photon targets or we could have photon targets or buffered. They're the two I know so far. And then you pass any of your parameters to that function as you would normally. So let's have a look at this set move speed. Okay, so there we have the function here. So it's just simply function with a name, and it's taking in a single parameter. The value is a float. So if we have a look at that, that's what we're doing here. We're calling the function by name, set move speed, and all the buffered targets on the network, all instances of your ship that are buffered, and then the parameter. So let's set that one up for the help as well. Okay, so we have a reference to the ship manager script component. Shipscript.photon view .rpc, and I actually haven't made a function yet. So, alright, let's just give it the set ship health. And that's going to be the function I have to create on the ship manager script. Again, photon targets, all buffered, and I'm going to be passing the parameter, which is the health variable I just created. What did I call it? Ship health? Yeah. Okay, so function name, the targets, the network, and a single parameter, which is going to be my ship health. So this is going to call that function, but it's going to call that function on every instance of my ship on the network. So let's set that function up on the ship manager. Just copy that. Okay, so set the ship starting health value. So if you're creating an RPC function and RPC and then go away with your function. Function, I called it set ship health, and it takes one parameter. Okay, now I think I have health on my ship, and I called it the same thing, ship health. Set ship health will equal the health value that has been sent to it. Now, this is on initialization, so I'll do the same thing as I did in the start here. I'm just gonna, I have a ship health which is basically the maximum health value. And then I have a current health, so as damage is done, that is taken off the current health. And then when I reinstantiate, I can just say the health the current health is equal to the ship health to bring it back to full. So that's initializing both values there. That's basically it. That's how you make a remote procedure call in Unity's JavaScript. Let's check for compilation errors first. Now, I did ask a question on Unity Answers about this program or downcast warning. Now, there's no way of typecasting these values. I've asked and the experts have replied. Where's the network serialization view? Okay, so when we're streaming our information to synchronize our objects with our brother or our mirror objects of ourselves on the other networks, we have a stream that's going. We either send our information or we're receiving information for all the other instances that are running on our end. Okay, in C# you can typecast them quite nicely in this little wrapper here. But there's no commands for JavaScript that will do vector3s or quaternions. I mean, you have parse a float and parse a int, and you can also have toString if you have a string that's being passed. But there's no way of typecasting these. Now, all Unity's saying in this warning is it's saying we're kind of implying this object is going to be a vector3. It's basically just saying, did you mean this, or you could have meant something else. It's just letting you know that that's what it's going to. Alright, so I think that's about it for RPC calls. I could show you quickly how I was looking at doing firing. So on the player manager, I'm managing my inputs. I'm getting the inputs here. I'm just checking if I'm got the fire button down or not. And then in the update, if we're initialize, I'm sending that input fire to the ship manager. Now, what does that ship manager do? It checks if I have an input, then it checks my bullet timer, like I can fire a bullet. So it's not every single frame I'm firing a bullet. I'm calling fire laser locally. So all this is happening only on my local machine. So it's only on the objects I can see, not over the network. So I fire a laser, I raycast locally. Now if I do hit something, so this is where I'm remote procedure calling all objects that have been hit. So I get the component of the ship manager script that I hit, and I say all instances on that network, I say, hey, you've just been hit. And I give it a damage value, I tell it where it was hit, and I also told it who hit it, which is me in this case. So let's have a look at this being hit. So this is a RPC call. Come down here, RPC call, been hit, how much damage, where was it hit, and who hit me. And then locally, I instantiate the explosion. So this is just something that's seen on the local machine. It's not instantiated over the whole network. But being an RPC call, everybody will see that local explosion. It's a bit weird, and it took me a while to get my head around. There's some things that you want to do locally, like explosions and bullets and things like that. And there's only certain things that you want to let everybody on the network know. For example, this RPC call saying been hit to all the targets of that ship, and the damage and the ID and the position. So that's about it. So that's how you remote procedure call in Unity's JavaScript. Most importantly, you do have to wrap your whole script within a class that extends photon.mono behavior. Once you've got all that going, then you should be away and rocking. Okay, so let's see if we've got this all working. Okay, so this guy's flying around and it's only shooting locally. see that line render message being sent through the RPC call so that my local machine also draws it as well. There he is. Turn up the banking speed. They're not aeroplanes, they're in space. There we go, that's about it.